Hello friends, this video on metals and non-metals part 10 is brought to you by examfear.com. No more fear from exam. So now we are going to talk about reaction with water. So we already spoke about oxygen. Now let us see how do metals react with water. Now under normal conditions, metal reacts with water to form metal oxide, but along with that it releases hydrogen gas. So that is how they normally react, normally all metals. And these metal oxides can further combine with water to form metal hydroxide. So basically, when you put a metal into water, it will immediately form metal oxide and some hydrogen gas. And this metal oxide in turn will again react with the water to form metal hydroxide. So by the end you will receive all metal hydroxide. But an important point to note is that all metals do not react with water. It is not necessary that every metal will react with water. Now we are going to talk about some of the metals and we will see how they react with water. So we will talk in terms of their chemical reaction. So let us first consider the first metal, that is sodium, which is Na. So let us see how sodium reacts with water. Now sodium again is very reactive. I told you before also, right, that these metals like sodium and potassium, they are extremely reactive. So sodium reacts vigorously and it reacts very fast with water. In this case also, if sodium is exposed to little bit of water, it can catch fire. So therefore, in your chemistry labs, all these metals are stored, right? But sodium is stored with special care because if you leave it exposed to air, it will catch fire. If you put it into water or if by any chance moisture comes in contact with it, then also it will catch fire. So how do you store sodium or potassium? They are stored inside kerosene oil because there is no water, there is no air. So there is no reaction. So that's how sodium is stored. And you should be extremely careful, little extra careful in fact, while you handle sodium. Now what would be the reaction when sodium reacts with water? So Na plus H2O, what does it form? It forms metal oxide plus hydrogen. Correct? But this metal oxide will again react with water to finally form metal hydroxide. So what would be the final product? One is hydrogen gas will be released and the second is metal hydroxide will be produced. So in this case, it will form sodium hydroxide, that is NaOH, plus hydrogen gas will be released plus lot of heat energy. Now, the heat energy which is released in this reaction is so much. So, the heat energy is so much that this hydrogen gas which is released, it catches fire. So, the hydrogen gas catches fire and that is why if it comes in contact with moisture or water, sodium catches fire. So, in this case, this water is nothing but cold water, normal cold water. So, even little bit contact with water can actually result in fire with sodium. Now similarly, if you look at the reaction for potassium, that is K. So what happens in that case? Potassium plus water, it forms potassium hydroxide plus hydrogen gas plus heat energy. So in this case, this hydrogen which is released, that is released in gaseous form. And what is this sodium hydroxide and potassium hydroxide? They are in aqueous form, that is aqueous solution, you can say. And this water is of course liquid. Here also water is liquid. So because of so much of reactivity, sodium and potassium are always stored in kerosene so that it cannot react either with oxygen or with water. So this is how these metals react. Now that doesn't mean that all the metals will react so vigorously with water. In fact, some of the metals will not react at all. So let us go ahead and look at some other metal. So the next metal that we are going to consider is calcium, that is Ca. So let us see how it reacts with water. So calcium reacts with water. So this will also form metal hydroxide, that is CaOH whole 2, calcium hydroxide, and hydrogen gas will be released. But in this case, the reaction is not as violent as sodium or potassium. So the reaction is less violent and the heat energy released in this case is not that much that it can catch fire, that hydrogen gas can catch fire. So less amount of heat energy is released during this reaction. But here also calcium can react with cold water. Like there are some metals which do not react with cold water, but when you heat the water they tend to react. So but in case of calcium they react with cold water. The next one we are going to talk about is magnesium, that is Mg. Now when magnesium reacts with water, what happens? Now here in this case it depends. Magnesium does not react with cold water. So if you put magnesium inside cold water, nothing will happen. There will be no reaction at all. But instead of cold water, if you put some hot water to magnesium, then what happens? Then reaction takes place and magnesium hydroxide is formed. Now in many cases I am not balancing the equations, so please you do that yourself. So in this case magnesium hydroxide will be formed. So reaction takes place only with hot water. So let us look at some other sets of metals. So the next metals that we are going to consider are aluminium, iron. So let us see how do they react with water. Now these metals, they do not react with cold water. So if you put them in cold water, there will be no reaction. Okay, so let us try with hot water then. It might react with hot water like how magnesium did. But in this case, we see that they don't even react with hot water. Okay, that's surprising. But now instead of hot water, if we take steam, that is boiling water, the water is boiled, so that is steam, then we see that it reacts. So how the reaction looks like? So the reaction is somewhat like this. Aluminium reacts with steam. Now this H2O is nothing but steam. So it is gaseous form of water. So this forms aluminium oxide, that is Al2O3, plus hydrogen gas is released. So if you want to balance the equation, here you go. Now similarly, iron, it reacts with steam, which is in gaseous form, to form iron oxide, that is ferric oxide, plus hydrogen gas is released. So this is how metals react with water, like this set of metals, aluminium and iron. So that's one way of reacting with water. Again, if you consider metals like lead, copper, silver, gold. So if you consider these metals, do you know how do they react with water? They do not react with water at all. So for these, they do not react. Whether it is cold water or it is hot water or it is steam, they do not react at all. So what did we conclude based on our study on reaction of different metals with water? We see that it really depends from one metal to another. Some metals are so vigorous, they react very fast with water. Some react with cold water, some react with only hot water, some reacts only with steam, and some do not react at all. So based on whatever we have learned so far, we saw that metals like sodium and potassium, they react with cold water itself, and that too they react very vigorously, so vigorous that it catches fire. Whereas metals like calcium, they react with cold water, but it is not that vigorous, so it is less violent. So in this case, the reaction is less violent, so there is no fire and all. Next is magnesium. Now magnesium do not react with cold water, it reacts only with hot water. Next comes aluminium and iron. Now they do not even react with hot water, they react only with steam. And finally, these metals like lead, copper, silver, gold. So these metals do not react with water at all in any form. So the metals vary this much in their reactivity with the same substance. So now let us see how do non-metals react with water. Now you will be surprised to know that non-metals do not react with water. For example, your carbon or sulfur or nitrogen, they do not react with water at all. In fact, those metals which are highly reactive with oxygen, for example, there are certain non-metals which are very much reactive with oxygen. For example, phosphorus. So whenever phosphorus is exposed to air, what happens? It is highly reactive. So it combines with oxygen to form oxides of phosphorus. So phosphorus is highly reactive in air, that is in presence of oxygen. Therefore, but at the same time it doesn't react with water at all. Therefore, phosphorus is stored in water. So see, that is another interesting fact. So this is how we store phosphorus. So just see, inside you have white phosphorus. So because we already learned, right, this phosphorus is so reactive that if it is exposed to air, it can catch fire very easily. So to prevent that, it is stored inside water, inside a bottle. So now it is no more in contact with air, and anyways it doesn't react with water. So this is again another point of difference between metals and non-metals, that metals react with water and non-metals do not. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.